solving equations using algebra. We can solve an equation using algebra. So to help us visualize the equation, we think about a model such as the balance scales or algebra tiles. So we started with those two models because it helps us see what is going on in a more visual way. Now, we do the same thing and we use the same steps when we actually solve using algebra. So to solve an equation, our main goal is we need to isolate the variable on one side of the equation. And I did talk a little bit about this when we did the other. So isolating the variable, really, that just means get the variable by itself. Okay, we want one variable all by itself on one side of the equation. So to do this, we get rid of the numbers on that side of the equation. When we solve an equation using algebra, we must also preserve equality. So just like we had to make sure that our balance scales stayed equal and both sides of our algebra tiles stayed equal, we have to do the same when we're working with algebra. So basically what we're doing is we're going to be working with just numbers and letters, so just numbers and variables. So example 1. Oh, and it says whatever we do to one side, we must do to the other. So you've heard me say that a bunch of times. You're going to hear me say it a bunch more. What we do to one side, we must do to the other. So example 1, Fabian charges $3 for each bag of leaves that he rakes and $5 for mowing the lawn. On Sunday, Fabian mowed one lawn and raked leaves. He earned $14. How many bags of leaves did Fabian rake? So the first thing it asks us to do is to write an equation. So first thing we need is a variable. So we're going to let, and he has bags of leaves, so let's let B equal the number of bags of leaves that he raked. So once we have a variable, then we can write an equation. So we know that he gets $3 for each bag, but we don't know how many. So 3B, and he mowed one lawn. So one lawn is worth $5. So 3 times the number of bags plus $5, and he walked away that day with $14 overall. So that is our equation for the problem. Now, part B is asking us to use algebra tiles and symbols. So I'm going to use both. We are going to move away from that. I know I promised you we're not going to draw tiles forever. If you like drawing tiles or drawing balance scales, keep doing it. It's only going to help you. But what we're going to do in this example is I'm going to show you the tiles and how we record that algebraically or using just symbols. So I'm going to start with drawing out this situation. So I have 3B plus 5 is equal to 14. All right, so this here I would record just as at the top, 3B plus 5 equals 14. So the next step, if I were solving this, is I would need to get rid of these 5 here. So I would add 5 negatives. And when I add those 5 negatives, all of this becomes 0 pairs, and I take them away. Now what I do to one side, I have to do to the other. So I need to have -5 here as well. 1, 2, 3, 4, 5. Good. So how am I going to record this algebraically? Well, I added a -5 to this side and a -5 to that side. So what I can write is 3b plus 5 minus 5 equals 14 minus 5. Makes sense? I have 5 positives, 5 negatives, 14 positives, and 5 negatives. Now, I do need to take these away here. So this group becomes 0, and that group becomes 0. So let's rewrite our next step for our algebra tiles. So I have 3 variable tiles left. My little equals squiggly. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9 tiles left here, and I'm going to divide them or put them in 3 rows. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, the way that I would record this algebraically is I'm going to have 3b is equal to 9. Now let's take a moment and see what happened. Here I had plus 5 minus 5. Well, when I have that plus 5 minus 5, that just equals 0. So those cancel each other out, and I'm left with just 3b. And here I have some math that I can do. So 14 minus 5 equals 9, which is what I get on the right-hand side of my equal sign. The last thing that we do when we have this is we need to look at that one grouping. So here I have that one grouping, and I know that my answer is going to be that b is equal to 3. So I need to do something here to show b equal to 3. And so what I've actually done is I've divided, and I've chosen just one group here. So I have divided this side by 3. And what I'm going to do on this side is what I do to one side, I have to do to the other. So 3 divided by 3 gives me just b, and 9, or 1b, if you want a 1b, that's okay as well. 9 divided by 3 is 3. So we have that same answer. Now, when we are looking at algebraically, we often look at what's happening and look for the opposite. So when we do the second example, I'm going to explain it in a slightly different way that works better just algebraically. So this kind of shows us how everything comes together, and then we're going to hear a little bit of a different script for your head when you're solving an algebraic question as we go. Now the last part of there, we don't want to leave it out, is to verify. So part C, we're going to start with that initial equation. 3b plus 5 equals 14. Plug that 3 in. 3 times 3 is 9, plus 5 is 14, which is correct. So that is the first example, and we are going to do a second example here as well. Now, as you guys have probably guessed, it can be inconvenient to model equations. Modeling equations works very well. But if I have really large numbers, it becomes really not so fun really quickly. And so it can also be a problem if we have fractions or decimals, because how do we represent that when I'm drawing a circle to represent 1? And so this is where we really move to working into algebra. So we have an equation given to us, 16t minus 69 equals -13. And we're going to use algebra to solve this. And so I'm going to give you a little bit of a different script this time. that might be more helpful when we're working strictly algebraically or strictly with symbols. So I'm going to start by rewriting this equation. Now remember, our goal is we want to get this t all by itself so that we have t equals. That is the ultimate goal. So the first thing that we need to do to get that by itself is to get rid of this negative 69. And so I always think about it as right now I'm subtracting 69. So what do I have to do that would be the opposite to undo subtracting 69? And that would be to add it. And a lot of students like to do it vertically. So you can write it like this. What I do to one side, I have to do to the other. If you prefer, sometimes students will like to write it like this as well. Either way works. Both are correct. Whichever you prefer, use that one. I'm going to do it vertically. A lot of times I find that we like it vertically because we think of adding and subtracting things vertically. Again, though, we are using our calculator, so it doesn't really matter which way we do it. So when I have this, I'm going to have minus 69 plus 69. Well, that's just equal to 0. So on the left-hand side, I am left with 16t. And on the right-hand side, I'm going to pull out my calculator, or you can do it in your head, your choice. We are going to pull out the calculator and we are going to do negative 13 plus 69 is going to give me an answer of 56. So once I'm here, I'm still working at getting just t equals. Now, in order to sort of understand what we're going to do, we need to think about what is happening between the 16 and the t. There's an operation going on, and we know that that operation is secretly multiplication. And the only reason why we don't write it is, 1, mathematicians are lazy, and 2, if we have 16xt, it becomes confusing as to whether that x is a multiplication sign or maybe it might be a variable. So I have 16 times t, and I want to undo multiplying t by 16. So the opposite thing of multiplying is dividing. So I'm going to divide this side by 16, which means I'm going to divide this side by 16 as well. So 16 divided by 16 is going to give me 1t, or just t, whichever version you like. And when I go into my calculator and I do 56 divided by 16, I'm going to get 3.5. Now, this is the first time we've had a decimal. So I don't really know. Is it right? Is it wrong? Did I press something wrong on my calculator? Luckily, we have part B, the verify, to help us know if we got the right answer or not. So part B, I'm going to plug this 3.5 back into my original equation. So 16t minus 69 equals negative 13. 16 times 3.5 minus 69 equals negative 13. 16 times 3.5 is going to give me 56 minus 69. Remember, this is going to tag along. It's that annoying sibling. Hasn't been dealt with yet. And then 56 minus 69. Put that in our calculator and it will give us negative 13. Negative 13 is equal to negative 13. So 3.5 is the correct answer. So you guys have some practice questions there. We're going to work on this today. We're also going to continue working on this on Monday. This is something that is going to take some time, guys. I know that sometimes it's nice just to get it right off the hop, but this is something you guys might have to work at a little bit before you're comfortable and confident as to what to do next. So don't feel bad. Ask me questions if you have them. We are going to do a live lesson on Monday starting next week. So that should give you a little bit of a helper, and we can work through some extra equations, and you guys can ask some questions as we go through.